Assalamualaikum everyone, welcome back to this channel. This is me Ali Wahid and you are on the channel of Medicare. So as you know that we have started the lectures of pharmaceutical chemistry and in which we have discussed the chromatography and all the types of chromatography, column chromatography and thin layer chromatography. Now we are moving toward the second chapter, which is about the spectroscopy. So in this we will discuss all the types of the spectroscopy, but in this section we will give the introduction to the spectroscopy, that what it is. So this is very important chapter for the paper point of view, so please listen it to the last end. So what is spectroscopy? So what you are doing to do, so this is a branch of science. Okay, so first of all you have to define it, that it is a branch of science that deals with the study of. Now what thing you will study in spectroscopy? So you will study a interaction, you will study a interaction, you will compare two things. What you study? The interaction between two things. The first thing is your matter, you can say your sample, and the second thing is your electromagnetic radiations, or you can say the light or matter can be called as the sample. For example, you have given a sample of NaCl, for example, and I said to you that please study do the spectroscopy of it. So you will fall the electromagnetic rays over your sample, which is NaCl, and you will study the spectrum of it, like how what kind of spectrum came out of it. So after studying the interaction you will get a result which is called as spectrum. Okay, what thing is occur inside this spectrum? Actually, your NaCl, your sample will absorb or emit this light, this rays. Okay, whenever, for example, this is your sample in a dish. This is NaCl I have given to you, and you have to fall the light over it. So this is the source of light. Okay, for example, and the light came over it, and your NaCl, some of these rays are absorbed into the NaCl particles and some are emitted out through the NaCl particles. Okay, so these kind of things are happening there. Some are absorbed, some rays are absorbed, or some are emitted out. And your spectrum will detect all. Your spectrum will detect how much light is absorbed and how much is emitted out, and your spectrum will give result in the form of a graph. It will makes a graph having different kind of peaks, such as like this, and it shows you the peaks like that, and it will shows the bond it has, like NaCl, it will show the bond in it. Okay, the covalent bond in it, and it also shows the presence of double bond or triple bond. For example, NaCl has a single bond. If we consider alkane, alkenes and alkynes, for example, we have CH2 double bond CH2, so it has the double bond. Now this double bond is shown by a peak inside the spectrum. So by using the spectrum we can detect that this compound has a double bond, this compound has a carbon, this compound has another carbon or two hydrogen it has. So we can detect the presence of double, triple or single bond, and as well as we can also detect the element it has. So for example, I have given you a unknown sample. You don't know whether this sample has double bond, triple bond, single bond, or whether which kind of element present in it. You don't know. And I will say to you, do the spectroscopy and find out which compound it is. What is the name of this compound? You will do spectrometry. You will get a spectrum, and by using these peaks, by observing these peaks, you will find out whether this bond contain double bond and what compound it is. For example, this peak shows that it has double bond, then you will make it. Then this peak shows it has two hydrogen, it has two carbons, then you will find out that it is a alkene. It is a alkene compound. Similarly, you can detect any sample by this method. So this is the basic concept of spectroscopy, and I have tell you what things you can do in spectroscopy. And for this purpose, to detect any sample, to detect all the elements and bonds in a sample, we do spectroscopy. So this was the definition of spectroscopy, and I hope that now you will understand that what things are we studying in it. Okay, after that we are going to study what is photometry. So actually these terms are very closely related to spectroscopy, so that's why you should know about them. So the word photo mean light. Always the word photo mean light, and metry word mean to measure anything. So photometry, it can be defined as the measurement of amount of the light falling on any on any sample. So ये जितनी भी light, this light, the amount of this light you are throwing over your sample, to measure the amount how much light you are falling, this is done by a photometry. Okay, so every sample has a different nature. So according to the nature of the sample, we throw the specific amount of light on that sample. So specific amount of light is very necessary, because if we throw a lot excess of the light, it can cause destroying or deterioration of the sample. So that a specific amount of light is thrown over the sample to check the results of it, to observe the spectrum of it. This is called photometry. The next term that used in the spectroscopy is the spectrophotometry. Now, spectrophotometry. So, it is defined as measurement of the amount of light that is thrown over a sample and at a selected wavelength. Okay, we do a selected wavelength, and at which wavelength it is thrown. This is called spectrophotometry. So actually, we are throwing the light over our sample and observing its spectrum. This whole concept is called as spectrophotometry. Okay, and this is depending upon the amount of light we are throwing over our sample. Okay, now we will study what is EMR. We will detail study that what it is. EMR, as it is abbreviated as electromagnetic radiations. Okay, so now study EMR. It's mean this rays contains electric field as well as the magnetic field. These rays are the combination of two fields. Okay, now these radiations contains different photons. You have know about the photons. They are the packets of energy. They are the discrete packets of energy. Sorry, energy. Okay, so we will put our photons over our sample and we will see that what kind of it is. Okay, so EMR is the photon and containing different packets of energy, and we will throw these packets of energy over our sample. And what is photon? Okay, photon, the other way to define a photon is that this photon is consist, it is a energy, and it consists of two things. First, it consists of oscillating electric field, which is abbreviated as E, and it also consists of the second thing, which is oscillating magnetic field, which is abbreviated as the M. So now your photon has two oscillating things. First is the electric field, second is the magnetic field, and both fields are perpendicular to each other. For example, if you say this is the source of the light, okay, and this is the light ray, and this is your sample of anything. Okay, this is the your sample of anything. Now this ray is consist of two things. It consists of oscillating electric field as well as it consists of oscillating magnetic field, and both are perpendicular. How? Now first of all, these are oscillating, and the wave that oscillate is travel like that, like this. A oscillating wave always travel like that. Okay, so now, okay, so now first I am drawing the electric oscillating wave. So this is the electric oscillating wave that is traveling there in that way. Okay, and moving toward the sample. Now it not only consists of only one. Our photon consists of magnetic field also along with the electric field. Now your magnetic field would travel like that. It is like that, and it is like this. Now you can clearly observe it. ओके, सो लाइक दिस है द पैटर्न ऑफ इट. सो ये इस तरह है, इस तरह जा रहा है. ठीक है, यूँ बाहर की तरफ आ रहा है. इट इज़ लाइक दैट. और वो ऊपर की तरफ जा रहा है. फिर ये उसके पीछे की तरफ जा रहा है, और ये नीचे की तरफ है. ये फिर आगे की तरफ और वो पीछे की तरफ. ठीक है, तो इन दोनों के दरमियान 90 डिग्री का एंगल है. 90 यानी एक अगर इस तरफ है, दूसरा इस तरफ है. ठीक है. सो दिस इज़ द फोटोन, दिस इज़ द इलेक्ट्रोमैग्नेटिक रेडिएशन जो हम अपने सैंपल के ऊपर डालते हैं. ओके, अब इन इलेक्ट्रोमैग्नेटिक रेडिएशंस की एक फ्रीक्वेंसी होगी, एक वेवलेंथ होगी. अब वेवलेंथ और फ्रीक्वेंसी क्या होती है, ये चीज़ें हम लोग देख लेते हैं. ठीक है, व्हाट इज़ फ्रीक्वेंसी? फ्रीक्वेंसी को हम एफ बी से भी डिनोट करते हैं, वी से भी डिनोट करते हैं. सो द नंबर ऑफ टाइम्स इलेक्ट्रिक फील्ड रेडिएशन ऑसिलेट. सो द नंबर of times of oscillation of your electric field or your magnetic field in 1 second. ठीक है, and you donate the frequency with the hertz, and 1 hertz is equal to 1 cycle per second. Okay, so the number of times our electric field oscillate in 1 second, it is called the frequency. Now what's the wavelength is? So wavelength is the distance between the two crusts and the two troughs. So this is your normal electric field, and the distance this is the crust, and these are the two troughs, and the distance between them is called one wavelength. Okay, now the distance from here to here is also the one wavelength, and the distance between this side, or sorry, not that, and this side is also one wavelength. Okay, so you should know about what is the wavelength is. So distance between the two crusts and the two troughs, and also at any point distance between the two faces is equal to one wavelength. Now the relationship between the frequency, between the energy, or between the wavelength is very important. You should know that what is the relation between them. So the major thing is the relation is through this equation. V is equal to f lambda. You have heard this equation many more. F is the frequency, wave, this sign is the wavelength, and V is the velocity, you can say here. V can also be denoted by the C, and F can be denoted by the V symbol. So this equation can be like that. So if someone give you this equation, you should know it is indirectly this equation. And the equation of energy is equal to V, E is equal to HV. E is the energy, H is the Planck's constant, and V is indirectly showing this frequency. Okay, now if we came out the frequency, then V our lambda. Okay, and if we say frequency as the V, then the equation will become C our lambda. Okay, now we will put this equation into in place of the V. E is equal to H C over lambda. So here E is the energy, H is your Planck's constant, C is the speed of light, and this is the lambda, which is the wavelength. Okay, now you have studied that the relation between E and C, which is the speed of light, which is the V, which is the frequency, is directly related. So as the energy increases, your frequency will be increases, but the relation between energy and the wavelength is indirectly. So it's mean as your energy increase, your wavelength will decrease. So this is the major concept that you have to make within your mind. Anyone can ask you in the viva question, in the MCQ. So you should know that whenever the frequency is increasing, it's mean energy is increasing. Whenever frequency is decreasing, it's mean energy is decreasing. And similarly, the relation between frequency and lambda is also like the energy has. So our frequency is also indirectly related to the lambda. As the frequency increase, lambda will decreases. Okay, so this was the major thing that we have to know. Now our electromagnetic spectrum. So what our electromagnetic spectrum say? Let's study about it. Now this is our electromagnetic spectrum. It start with the gamma rays, then X-rays, then UV rays. So now your gamma rays and your X-rays, they have very high energy. They are very high energy. High energy. It's mean they have very high frequency, but their wavelength will be very low. Okay, so their wavelength is like these rays are very close to each other, very close. And as we move from gamma to X-rays, this wavelength is a little bit increased, because now the gamma rays have highest energy, like we show it with the three arrows, highest frequency. When move toward the X-rays, this energy is a little bit low, but it is high, but a little bit low from the energy of gamma rays. That's why a little bit of this wavelength is increased, a little bit of. Okay, so now this increase is shown by a little bit of the difference. Now you can see the distance between increase as it here it is, and it will increases. This distance is furthermore increased when we move toward the UV part. So it will increase. Like further, I have gradually increased it when we move to the UV part. After the UV part, we have the visible portion. Here the distance is again more increased. As you can see, when we move to IR, it increase further, distance is increased. Then we move to microwave, it increase further, like that. And then we move to radio waves, this distance is further increasing. Okay, so that's why when we move from gamma rays to radio waves, the energy is gradually energy frequency and they change. And when we move to radio waves, it have lowest energy, it has lowest frequency, but it has highest wavelength. So this is how that when we move from the gamma rays to the radio waves, this is how the energy frequency and the wavelength increase or decrease, they change. Okay, so now we actually, these what are gamma rays, X-rays, UV rays? They are your electromagnetic rays. Gamma X-rays, that when you go for a X-ray, you do the X-ray of your body, and you are throwing these kind of rays over your body. Okay, and if someone is throwing gamma rays, for example, to kill the cancer, we throw the gamma rays. So if someone patient is going for a radiotherapy, he is throwing gamma rays, these kind of rays over his body. Okay, similarly, you are going for ultrasound, you are throwing UV rays or ultraviolet rays, and these ultraviolet rays are also released by the sun. They and these rays are filtered by your ozone layer. So sun is throwing these rays over your body, but ozone is protecting you. But now ozone layer is is become thin, and it is not now the visible rays. These are the rays that are emitted by a white light. Now the lights that are given in your house, they are throwing the white light over you, and you can see this light. So this is called the visible region. So now the all the light that is thrown by your sun that you can see, okay, ultraviolet rays are not, you cannot see the ultraviolet rays which are thrown by the sun and which are filtered by your ozone layer, but you can see the visible rays that are thrown by the sun or by your light bulbs that are present in your house. Though they are visible, they are throwing the white light within your house, and you can see this white light. And when you, like, this visible rays are coming, and when you place the prism within their place, you will observe the seven patterns, seven colors: red, blue, pink, these kind of colors you observe. You have remember their pattern, okay? So this visible ray has the components in within it, which is separated when you place the prism in it. Similarly, when a rainbow forms, you have observed the same color, same seven color pattern is observed when the rainbow form. So rainbow forms when the water droplet, when the rays coming from the sun and the water droplet placed in it, when we see when the rain, slightly rain is coming out drop by drop, and the sun emerges out, and when the sun rays fall on the water droplets, when a lot of water droplets, then they form the pattern over all the sky of seven color pattern, and we see and we call it a rainbow. So it is actually the dispersion of a visible light, and which shows you seven colors. Similarly, when we move toward further of visible ray, you will become enter into IR, which is the infrared radiation. So infrared radiation, it has three parts. It has three parts. First part is called near IR, mean near infrared radiation. Second part is called mid IR, and third part is called far IR, infrared radiation. Then microwaves came. These are the waves that are given here. Then radio waves having very low energy, very low frequency, but the wavelength is very high. So this is the electromagnetic spectrum. I have tried my level best to make it easy for you, and and similarly the understandable for you, because a lot of students cannot understand what it is, why they are explaining UV, what is IR, what is visible. So I have tried my level best so that I can make it easy for you and always rememberable for you, because a lot of student thinks that the concept of spectroscopy is very difficult, and they cannot understand it. But when you understand it, then it will never be unforgettable for you. And I have, I think, tried my level best to make it as easy as I can, and I have make it, and I hope that all the things are understandable for you now. Now in the EMR, we have some levels of EMR, some levels it has. First, we have seen the spectrum of electromagnetic rays. Now it has three levels. First level is the electronic energy level. Electronic energy level. In this level, like, this is your sample, or this is any molecule or atom which is present at the ground state, mean it is at the room temperature 37 degrees centigrade, okay? And whenever some light comes from any source, like this is a light source, and any light came over it or falls on this sample will excite, it will excite and move to the excited state. This is called the excited state, and this is the E naught state. Okay, ground state, it is observed as a lowest energy state, E naught, or the ground state, while this state is E1, excited state. Because whenever a molecule absorbs the light, so your light is the energy is the packets of energy. Now when a molecule observe energy, it will become excited, similarly as we human beings are. When we have no attention, no stress, we are at E0 state. At room temperature we have all the things settle down. But when a stress came in our life, when a stress came, we become excited, we goes to the upper part, our stressful activity occur within our brain, and that's why we become excited for it. So this is same thing happening with the atoms or the molecules that are present here. And why, what things make them excited? As you know, every atom has electrons in it, so these electrons become excited. The electrons which are present in the outermost bond, in the outer bond of it, like we have the hydrogen atom. So hydrogen one atom only has one electron in it, sorry, two electrons in it. Similarly, helium has two electron, hydrogen has H1 has one electron, helium has two electrons in the first bond pair. Next, as the atom increases, their outermost bond pair is increased. Like this is the atom, and the out it has three levels, and in the outermost band there is electron, and when the energy fall, this electron become excited and it will move toward the excited state. So this is called electronic transition. Okay, in which electronic transition equation is that E1 minus E2. Okay, so it has the highest energy. This electronic energy level has the highest energy. Now we will move towards the second level of the EMR, which is the vibrational energy level, VEL, vibrational energy level. So here when this is a atom, when the IR radiation, now we have the IR strong radiation, when they fall over your atom, they will move, they are at a one vibrational level, they are rotated like they are rotated in this directional, and with the speed of 22 kilometer per hour, just suppose. And when it absorbs, it will become excited, it moves to the higher state, and now it will rotate with the high energy because it has absorbed the energy with high amplitude. So but it has less energy than the electronic level, like its delta E is about from 0.1 to 10 kilocalories per mole, but the delta E of electronic energy level is higher than it, is higher, like it is from 10 to 100 kilocalories per mole. But the delta E of your vibrational energy level is low, that's why it has the low energy than it. The third and the last energy level of EMR is your rotational energy level, REL. So here your energy levels are very quantized and very discrete. Now your electron, this is your electrons, after absorbing a light or the energy, it can absorb anything, absorb it within it, or it can eliminate anything, any radiations. So it has more less energy, its delta E of rotational E is less than the vibrational E. So now if we compare all the energy levels, so the delta E of rotational is smaller than delta E of vibrational, which is smaller than delta E of electronic. Okay, so this is the pattern here. You can opposite is that the delta E is highest than the delta E V vibrational, then the delta E radiational. So the delta E radiation, the delta E mean the electronic transition given by the radiation, sorry, rotational energy level is the lowest, while the delta E electronic transition of electronic energy level is the highest. So you should know the energy difference, energy transition difference between all of them. So we have covered the levels of EMR. We have discussed three levels of it. Now your principle of your spectroscopy. What is the principle of it? So the major principle is that we are measuring. So your spectroscopy is based on the measurement of, we are measuring the intensity of light. Intensity of light which is absorbed or which is emitted by your sample. So your sample, how much amount of light fall on it, how much light it emits out. For example, it emits out this amount of light, it emits two rays, and how much it absorbed within this one light. This is called spectroscopy. This is the principle of your spectroscopy. Okay, and what is spectrum? So you should know about what is spectrum. Spectrum is a graph that shows the intensity of the light which is absorbed or the intensity of light which is emitted out. Okay, and spectrometer, you can say, it is used to measure that intensity of light. Okay, to measure it, this is an instrument that will measure the spectrum, that will measure the intensity of light. Okay, so spectrum is a graph, while spectrometer is a instrument that measures the intensity of light, while spectrum is a graph that shows the intensity of light which is either absorbed or either emitted out through a sample. Okay, now we have two types of spectrophotometer. We have first of all we have some types of spectrophotometer, you can say here. We have two types of it. First is the single beam spectrophotometer, and second is the double beam. Okay, single beam, in which only it's a device that measures the absorption of only one single beam. For example, this is the light source, it's throw a lot of light. Now we place the monochromator along it. So monochromator is a device that select only one wavelength. Chromator select one wavelength, it fall over the sample. Now from this it goes to the detector, and detector shows it on over the computer. Now in the double spectrometer, we have the light source, we do the monochromator. Now the monochromator throws have the mirror, two mirrors over it, and the monochromator throws two kind of wavelength over your sample, and then it will detect it or shows in a detector. Okay, this is a concept of single beam and double beam spectrophotometer. We have some other types on the base of their range or the type of the light used. We have some other types of spectrometer as well. We have UV visible spectrophotometer, we have IR spectrometer, we have atomic absorption spectrometer, we have atomic fluorescence spectrometer, we have X-ray fluorescence spectrometer, we have mass spectrometer, we have laser induced breakdown spectroscopy. So these are all the types of spectrophotometer that we can use. Now the last thing that we have to discuss about our spectrophotometry is the types of it. Similarly, the types it has two types. First is the absorption spectrometry, AS. Second is the emission spectros. In the absorption spectrometry, it is an analytical technique which is used to consent the measurement of absorption of EMR. कि एक light sample, how much amount it absorbs. Only in AS we will discover the amount of light that is absorbed, and in E emission spectroscopy we will measure amount of light this sample absorb or emit out. Okay, and how much it absorbs. Okay, कितना इसने absorb कर लिया और आगे emit out नहीं करने दिया. For example, we have a graph here, and this is a sample, and it show highest peak at this wavelength. Now this is the absorption. and now here the wavelength is shown. For example, here the wavelength is 270.5 nanometer. So this is the wavelength at which it shows the maximum peak, or it's mean this is a light wave at which it shows the maximum absorption. So we have UV part where the wavelength is from 10 to 400 nanometer. So it's mean this sample absorb this of the wavelength, and it's mean the light we have thrown over it is the UV visible rays. Then it shows the peak, and then we can measure that it absorbs the wavelength of 270.5 nanometer. Similarly, in ES, in the emission spectroscopy, we can measure the amount of light that is emitted out. We can measure which visible region it has. The example of emission spectroscopy is the mass spectroscopy, and second is the atomic emission spectroscopy. Okay, these two examples it has. Okay, so this was all about our today's lecture. I hope that you find this video well, and I think all the your concept will be clear. If you still have some confusion, then you can tell me in the comment section, and I will give answer to you. So make sure to subscribe this channel and press the bell icon so that you can get the notification of all the videos that I will be uploaded in the future. So take care. Meet you soon in the next lecture. Allah Hafiz.